Alright, so this is another question for the same year of Maths 102 223/224. This is question 1B, and it says find dy dx from first principle given that y is equal to 3x cubed minus 5x plus 2. Right, so we were asked to use the first principle to find dy dx from this. Ordinarily, we can just find dy dx here. If I move this one here, reduce the power by 1, I have 9x squared, then minus 5. That will actually be the answer without first principle. Alright, without first principle, without using the first principle, my answer will just go straight. I'm just having it straight up to be 9x squared minus 5 by using L'Hopital's rule. But in this question, we are asked to use the first principle to find dy dx of this. The dy dx of this, right? So we are given y to be equal to 3x cubed minus 5x plus 2 here. That's the question. And then we are asked to find dy dx from first principle. Right? So from first principle, we have that dy dx from first principle, we have that dy dx is given by the limit as delta x tends to 0 of f of x plus delta x minus f of x, alright, over delta x. Right, so this is the first principle. So we are going to be using this approach to get the dy dx of this. Right, so an increase in y will cause a corresponding increase in x. Right, so from the given question, we have y equal to 3x cubed minus 5x plus 2. So like I said, an increase, I'm going to increase y and also increase x. So I have y plus delta y, right? So this is a change. A change in y here will also cause a change in x. So I'm going to be having here 3 into, so my x will also change. I have x plus delta x raised to power 3 because there is 3 here. So my x here is just what is changing. It's from x to delta x. Then I have minus, I have 5. And I have x. The x will also change, x plus delta x here, then plus 2. Right, so this is what I have for this guy here. So we are going to be expanding this. We're going to be expanding this using the knowledge from Pascal's triangle. Automatically, we can just repeat this thing 3 times. So for exam's sake, you can use Pascal's triangle, so it can be faster. Pascal's triangle, for faster method, you can use Pascal's triangle, where you have your coefficient for the third degree to be 1, 3, 3, 1. 1, 3, 3, 1. So 1, 3, 3, 1. Right, so in subsequent videos, we'll talk about the Pascal's triangle and it will be explained in details. But the course of this video, we are going to be going straight up to it, so we can just get the answer for the problem. All right, so we are going to be having y plus delta y here to be equal to 3 into, so I have my coefficient to be 1, 3, 3, 1. 1, 3, 3, 1. So it means that x is reducing from 3 to 0, y dx is increasing from 0 to 3. So here will be x raised to power 3 plus the next coefficient after 1 was 3. So I have x squared delta x plus the next coefficient there is 3. 3x delta x squared. Then the next coefficient there is 1. Delta x cubed. So you can see that x here is reducing from 3 to 0, while delta x is increasing from 0 to 3. So I have minus 5 into x plus delta x plus 2 here. All right, so this y here, I'm going to replace it. I'm going to move it across the equal to sign. And when I do that, the sign will change. So I'll be having delta y equal to, so let's just open up this bracket at once on the process. So we have 3x cubed plus 9x squared delta x plus 9x delta x squared plus 3, right? Right, so plus 3 delta x cube. I have minus 5x minus 5 delta x plus 2, then minus y. And my y here has an expression already, which is 3x cube minus 5x plus 2. So we'll just replace it here. So I'm going to be having delta y to be equal to 3x cube plus 9x squared delta x plus 9x delta x squared plus 3 delta x cube minus 5x here minus 5 delta x plus 2, then minus y. Y is 3x cube minus 5x plus 2. That's my y here. So I'll be having, opening up this bracket here, I'll be having delta y to be equal to 3x. Be having delta y to be equal to 3x cube plus 9x squared delta x plus 9x delta x squared plus 3 delta x cube, 3 delta x cube minus 5x minus 5 delta x plus 2. Then this and this will give me minus 3x cube. This will change to plus 5x. This will change to minus 2. Right, so you notice that this is minus 3x cube and this is 3x cube. So this and this can cancel out. This is 5x and this is minus 5x. So this and this can also cancel out. This is minus 2 and this is plus 2. So it can cancel out. So I'm left with delta y to be equal to 9x squared delta x plus 9x delta x squared plus 3 delta x cube minus 5 delta x. So in this case, I will have to divide both sides by delta x. So if I divide through by delta x, I'll be having here delta y over delta x to be equal to 9x cube delta x over delta x here plus 9x delta x squared over delta x plus 3 delta x cube over delta x minus 5 delta x over delta x. So from this point here, I'll be having delta y over delta x to be equal to, so this can cancel out this, I'll be left with 9x squared plus, when this cancels out, I'll be left with 9x delta x plus, I have 3, this can cancel this, I'll be left with 9x squared, 3 delta x squared, while this cancels this, I'll be left with minus 5. So it means that my delta y delta x is this. So next up here, I'm going to substitute, or I'm going to take limits of both sides. Taking the limits, I'll be having dy over dx. Going back to this expression now we had, that's where this expression comes in. Delta dy over dx to be equal to the limit of this whole expression here. Alright, so I'll be having dy over dx to be equal to the limit as delta x tends to 0 of delta y delta x here. So my delta y delta x here is the whole of this expression. So I will be having dy dx to be equal to the limit as delta x tends to 0, of 9x squared plus 9x delta x plus 3 delta x squared minus 5. So when I substitute delta x equal to 0 here, I'll be having dy over dx to be equal to 9x squared plus 9x into 0 plus 3 into 0 squared minus 5, which will give me dy dx equal to 9x squared plus this will be 0 plus this 0, I have minus 5. So dy dx from first principle here is giving me 9x squared minus 5, which becomes the answer.